Why is HIV difficult to cure? If you ask me this question, can HIV be cured? My answer will be yes, but not exactly. HIV has been declared cured before, but only under special circumstances. The next step in HIV cure research is to develop a safe, scalable method that can be affordable and available. Meaning HIV is curable but the cure is difficult, so to say, as of the time of making this video. So the next logical question will be, why is it so difficult to cure HIV? To explain why, we'll list the top 5 challenges in HIV cure research, and then explain how new gene therapy techniques may finally make HIV cure research a success. 1. The first problem is that HIV is a retrovirus with a high mutation ability. They have the ability to exist in RNA form, then transition to a DNA form to become a permanent part of the cell they infect. The cell can then read the DNA master copy of HIV repeatedly and make new RNA versions of HIV to export to other cells. During the transition from RNA to DNA and DNA to RNA, errors can occur, giving retroviruses like HIV the high mutation rate of an RNA virus with the permanence of a DNA virus. The mutation rate allows for the rapid generation of a wide diversity of HIV variants, which is a major contributing factor in the failure of the immune system to eradicate the virus. 2. HIV infects immune cells. Another major hurdle to curing HIV is that the virus infects and adversely affects immune cells, the very cells that are required to fight an infection. HIV mainly infects the subset of immune cells called CD4, helper T cells, which play a central role in the immune system. So, when HIV kills helper T cells, it causes immunodeficiency. Additionally, since HIV can hide in the DNA of a helper T cell, when the cell divides, its daughter cells carry the HIV genome, creating new HIV-infected cells without the need for cell-to-cell spread of HIV. The T cells of the immune system divide in response to pathogens, so ironically, T cells that are meant to fight HIV now manufacture more HIV-infected cells and become a major source of the virus in the body. 3. HIV establishes latent reservoirs. Viral latency is another major obstacle to an HIV cure. In a nutshell, latency is when a virus infects a cell but does not immediately begin creating new viral copies. Latent, resting HIV-infected cells can remain in reservoirs in the body for months, or even years, and become active at any time. Since current antiretroviral treatments target HIV itself, these medications are unable to eliminate latently infected cells because they are not actively producing viral particles. For the same reason, latently infected cells cannot be identified and eliminated by the immune system. Thus, eliminating the reservoir is the biggest challenge for the scientific community. Note that a full functional cure for HIV would need to address the infected cells of the viral reservoirs whenever they show themselves. 4. If I ask you to choose between HIV cure and HIV eradication, which one will you choose? By minimizing new infections, it is possible to eradicate a disease without the existence of a cure. In fact, that's how we got rid of smallpox. So we can eradicate HIV even without a cure. To achieve this, first people must gain awareness of their HIV status, then to begin treatment, and then to suppress the virus through the use of drugs and behaviors informed by their HIV status. While this approach does not provide aid to those already living with HIV, it is expected to control the spread of HIV, making it less and less likely that new infections will occur. This next challenge in the cure of HIV is very interesting and intriguing, because the problem is how we define cure. This becomes a problem because funds get diverted or spited between research for cure and research for eradication. The word cure has 2 definitions in HIV science. It looks simple enough to agree on what an HIV cure is, yet there are 2 different types of cures envisioned. Theoretically, if it were possible to eliminate all traces of HIV from the body, such an approach would be called a sterilizing cure. The other type of cure is a functional cure, in which the levels of HIV in the body would be kept below the level of detection without the use of antiretroviral therapy. In the case of a functional cure, the infected person would not need to be on antiretroviral medication, would not experience the effects of HIV, and would not transmit the virus to anyone else. This is a cure because there would be no need for antiretroviral drugs, ever, as opposed to a remission, in which there might be a recurrence of the disease. Finally, HIV is a curable condition, as exemplified by cases like the Berlin patient and the London patient. These cases show us that under certain conditions, HIV can be cured. The next logical step is to use gene therapy to deliver HIV resistance genes to immune cells, as the case in Berlin patient, London patient. We have a separate video on this and we will add a link to it in the description below. This brings us to our coming soon videos on gene therapy for HIV cure. Please subscribe to our channel so that you can be notified when we release the next video. Note that knowledge is advancing by the day and we will like to always post an update on new advances on how to stay healthy. You can contact us via the link in the description below for any medical inquiry. You are watching Zoom Hospital channel and listening to work of Dr. Kayode.